Okay, we're doing the same type of probing cycles as before. We're just doing a web measurement in the X to get the center line of the part. The fixture offset's going to be on the center and the top of the material minus 0.010 of an inch. So there's the Y, 0 point. Here's the Z, and then we're going to have to set it in 0.010 of an inch. I've got the part clamped here with no parallels underneath it, so I've clamped it quite tightly in the vise because I'm going to drill holes all the way through and it would hit the parallels. That's the reasoning on that. Here's our fixture offset. Now, right now it's in the absolute mode here. I've got to change it to incremental, so I got to enter in an I. You see it shifted it to incremental mode. I can go minus, well, let me get it on the fixture offset, which is going to be 43 here. And we're going to go minus 0.01. It should change that number. 0.010 of an inch. through, finally got the basic clamp done, less the bore. Now we got to screw these things together. Hopefully this all fits. Now, let's get up. That's shim. Look at that. Look at that. Look at that. Just take it off. Done. Look at it. You're right, fine. We're all. We're all here. I just take it off. Take it off. On the bottom of the plant. Got a roll. There's the this plant now. That's my easy way to go. I got one. Keep it clean. Okay, we're going to so line up. Here's our setup to bore this hole in here. You set the 0 and X here, 0 and Y here, and the Z0 here. And so we're going to bore, we're going to rough out and bore and mill this bore, and then we're going to mill this notch over here as well in this operation. Okay, I'm going to try to do this without coolant so we can see what's happening here. So let's see, let's go here. Let's see. This is a 1-inch ISCAR feed mill. Just doing a spiral helix in, rough the bore. Doing 1500 RPM and 45 inches per minute feed rate. And it's a 30 thousandths pitch on the helix. So 30 thousandths in for every revolution. I may have to blow some air in here. Look at those shavings. On the Mazak, I can run air through the spindle. But on this machine, I can't do that. Doesn't have that ability. Being a little bit conservative here because I don't want to just move anything or, you know, mess up anything. This is the last, except for cutting the radius on the outside, which isn't really critical. This is the last operation on the part. I don't want to screw anything up now. So I'm not really running this too fast. So we're going 600 RPM and 20 inches per minute. 100 thousandths depth of cut each pass. Here's the floor. here. Actually, it looks, the shank on that grinding thing is about right, exactly that diameter. I might want to take it a little bit bigger. Might rerun that programming for a finish cut here. See if it'll hit the camera or not here. It actually measures 1/1000th of an inch under the size I measured with the calipers, but this will probably actually, oops, should have blown the air in there. This will probably actually take it a little bigger. I'm gonna stop it right here. I don't need to rerun that. That was pretty good actually. Just want a little bit. That squeaking noise you hear is this platform. I need to yeah, see it cut it a little bit bigger. That's about right. See, the actual thing measured about 1.746. I got a couple of thousandths clearance. That would be better, just to make sure it fits in there. Nothing springs or something when I release it here too. The radius right here. Let me go deburr everything here so I don't cut myself on these burrs. And I'll just stick it like this and we'll cut that radius with the ball end mill. The power deal here, and you can hook 2 of these grinders in here, or motors, power pack, motor, whatever they call it. And right now it's set on 40,000. It'll go up to 50, and it'll go all the way down to 1,000, it looks like, I guess. Let's see if it comes on. See, it's rotating right now, but this is a constant torque motor, so it has a lot of power even down at that low RPM of 1,000. I don't know if I could demonstrate this. See, I can't even stall it at that RPM. I normally run it at 40,000. It will run with a lower duty cycle at 50,000. But I run it, it's kind of got a detent here on the knob at 40,000. That's what I run it on. So this is a ESPERT, I guess ESPERT 500 power unit, and this is the spindle here for the ESPERT 500, and this is the motor, I should say, in the spindle. And they make and you can turn it off and on with this switch right here as well. They make I think this is the high torque motor. I think there's one that's a little bit less power than this one, and they make different spindle units you can put on here to hold up to a 1/4 inch shank, I think, or they even make a little like filing thing and I think like a belt sander, a miniature belt sander, I think, something like that. There's about 9 different attachments that you can put on this motor. I only have this one. And also you can take by turning this, you can take the burr in and out of it. You don't have to use any wrenches. It's kind of nice. I've had it for a long time, maybe 15 years, and it still works fine. It is kind of expensive though. So we're getting close. We can just cut this radius on here, and it's finally done. Okay, we set the 0 here, X, Y, and Z 0 like that. We're just gonna cut this radius with the ball end mill, see if this works. I just made a real quick program. Hopefully it won't screw up the tool or anything. We'll see. Okay. I didn't really take a whole lot of care in making this program. I just want to, well, didn't want to do that because I didn't have the camera in the waterproof case. And it gets things kind of dried off here. I have the side off the camera even where the microphone mounts and everything. Hopefully that didn't screw anything up. We'll see. Here we go. Could have probably used a little higher plunge feed rate on this. Take it out, take it over there and deburr it. Next step, put it on the grinder and mount the thing and dress the wheel and see how it works.